We did multiplication, right? When you multiply two radicals, they don't have to be like terms, okay? So yesterday we only did number one. Number one, we just multiplied our numbers, multiplied our radicals, and simplified. But when you add or subtract radicals, so addition or subtraction, they must be like terms. And in order for them to be like terms, they need to have the same number under the square root or under the radical. So we're going to talk about all four operations: addition, subtraction, multiplication, and division today. We're finishing out Appendix 10. Appendix 10, that homework was shortened. Those are the numbers on the board. There are also the numbers that I told you yesterday, and there are also the numbers that are on Canvas. Homework 5 is actually going to be a worksheet. It's not going to be out the book at all. So just ignore homework 5 on that half sheet. All right, so the first thing we need to do is simplify. These are not simplified. So what does that mean? I'm not building a cake. But if we look at our perfect squares, we know that 2 squared is 4, and 3 squared is 9, and 4 squared is 16, okay? What I'm trying to figure out is, in order to simplify it, can I divide any of these numbers into 18 or 8? So let's start off with 18. Which one of these numbers will divide evenly, is a factor of 18? 9, right? Do you agree that 9 does divide into 18 evenly? 9 times what gives you 18? So this is what I'm going to do. I'm splitting this apart. So the -1 is still there. That -1 is still there. I'm not getting rid of that. But I'm taking that root 18 and separating it into the square root of 9 times the square root of 2. The square root of 9 is 3, but the 2 does not have a partner. If we were to build a cake, it wouldn't have a partner. So this would simplify down to -3 square root of 2. All right, so now let's bring down this addition sign and do the same thing with the 8. Can I divide 8 by 4? How many times does 4 divide into 8? Or 4 times what gives me 8?
2.
So I'm going to take, now this 2, that's right here, that's still there. I'm just going to bring that down. Nothing is changing, that's still there. But now I'm taking this 8 and breaking that apart to the square root of 4 times the square root of 2. So I know that the square root of 4 is 2. And then I can multiply these 2 times 2 and I'll have 4. Are they like terms? In order to be like terms, they have to have the same number under the square root, and they do. So what that means is I can add the number in front. So this is like saying -3x plus 4x. We're just adding the coefficient. So -3 plus 4 would just be 1. So my final answer is just the square root of 2. You can put the 1 in front of it. It's like you don't have to put a 1 in front of x. We all know that x means 1x. So square root of 2 means 1 square root of 2. And that would be your final answer. All right. Let's look at number 3. So Let's go back and look at number 1. So notice that when we did this yesterday, I did not need to make a box because we call this one term. This is one single term. There isn't a plus sign or a minus sign separating them. But when I look at number 3, this is 2 terms. And this is multiplication. So what we will do is make a box. You can use whatever method you prefer. So take a minute. I got it, Randy. Yeah, but thank you. All right. All right, go ahead and fill in the 4 squares. All right, so now we're going to multiply. So remember, we can multiply if they don't have the same number. So I can multiply the square root of 5 times the square root of 5, and I'll get the square root of 25. All right, and what is the square root of 25? It's a perfect square. 5. So this is going to change to just a 5. All right. Now, there's an invisible 1 in front of both of these. Okay, so what I'm multiplying in this square is the 1 by the -2. I'm not touching the square root of 5 because this doesn't have a radical to multiply it with. So -2 times 1 is -2 square root of 5. +1 times 3 is a +3 square root of 5. And then 3 times -2 is -6. All right, so now we have some like terms. We have 2 numbers that we can add together. When I add those together, I get -1. And I also have 2 radicals that are like terms. And when I combine those together, again, that's like a 3x minus 2x. That's just x, or √5. This would be my final answer. And when you write this on your quiz, test, whatever, you can flip the order. So you could put the square root of 5 minus 1. That's still the right answer. All right, so let's look at number 4. So the thing about radicals, remember, there's 2 things that we don't leave in the denominator. One is an I, the other one is a square root, okay? So what we're trying to do is get this 8 to a perfect square in order to eliminate the square root. So let me go back and list my square roots again. So I'm going to work this 2 different ways. So we know that 2 squared is 4, 3 squared is 9, 4 squared is 16, blah, 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 blah. That's really all I'm trying to get to. Okay, this is the easiest way. The easiest way to do this. I'm going to do it both ways. Okay, so first let's talk about if we take the highway. If we take the highway, the easiest way is to say, I'm trying to get this to be a perfect square. which one of these numbers can I change the 8 to with multiplication by a whole number? No, if I would have to take the 8 times a half. That's not a whole number. So we can't get to a 4. Can I multiply 8 by something to get to 9? That's a whole number. Can I multiply 8 by a number to get 16? What number? 8 times 8? 8 times 2. So this is the highway method. I'm going to multiply it by 2. And again, we can multiply square roots that are different. So that's going to give me the square root of 6 divided by the square root of 16. And the square root of 16 is 4. And that would be my answer. Now let's do it another way. And I try to show you different ways so you all can choose. If you don't recognize that we can multiply the 8 by 2, then just multiply it against itself. So if I don't recognize that I can change the 8 to a 16, let's just multiply it by 8. So multiply it against itself. And what that's going to do is give you the square root of 24 over the square root of 64. Now 24 can be broken apart to 4 times 6. Square root of 64 is 8. So now we have a 2 root 6 over 8. And then my last step would be to reduce. So you have an option. You can, see, this is the street way, but it's okay. We don't always have to take the highway. If you don't recognize that you can change the 8 to a 16, then just multiply it by itself. Take the 8 times 8. You're still going to get to the same destination. It's just a little bit of a longer route. But again, let me write this in your notes. No radicals in the denominator. That's so important. We cannot leave a radical in the denominator. All right, so now looking at this one, you see how this was just one term. We just had an 8. So we're going to do one a little bit harder. Let's look at number 5. Go ahead and copy down number 5. All right, so this is 2 terms. So in other words, I can't just multiply this by the square root of 2. Now, if this was only a square root of 2 and I took away this minus 1, I could do it the same way I did number 4. But this is called a binomial because there's 2 terms. So what I have to do is multiply by the conjugate. So think about the i's. If we had 3 plus I, what did we multiply top and bottom to get rid of I? 3 minus I. That's called the conjugate. We have to do the same thing here. I'm multiplying the top by the square root of 2 plus 1 and the bottom by the square root of 2 plus 1. So for my numerator, that's a lot easier to do. We're just taking the 5 times square root of 2 plus 1. And for my denominator, we have to make a box. And I always make boxes, but again, you don't have to. So there's an invisible 1 right here. I'm taking the 5 times the 1 and the 5 times the 1. So my numerator is simply going to be 5 root 2 plus 5. That's the numerator. All right, now let's find our denominator. Radical 2 times, or square root of 2 times the square root of 2 is the square root of 4. And what's the square root of 4? So this box is just going to have a 2. This box has a negative 1 root 2. This box has a positive 1 root 2. See how they're opposite? Every time you multiply 2 conjugates, something is going to cancel. And then my last square, I have a negative 1. So this goes away. And I'm left with just 2 minus 1. And what is 2 minus 1? 1. Now you could write your answer like this. I would not mark it wrong, but that looks weird. When we have a denominator of 1, we just don't write it. This is the better way. But again, I am not picky. I'll take either one. If you want to put the 1 under it, go ahead. Yes, Treasure. Right here, they're not like terms. You mean here? Yeah, this has a square root of 2 and this has a 5. So if this were a 5x plus 5, could I add that and say it was 10x? No, same thing. It has a square root of 2. They're not like terms. We have to keep them apart. Okay, it is. The square root of 2 times the square root. I didn't show my work. I'm sorry. I should have. I'm going to. But in this box was a square root of 4, and I just changed that to a 2. Okay, I just didn't write that. But yes, we went from square root of 4 to a 2. Okay. All right, let's look at number 6. Does anybody need more time to copy down 5 before I take it off? All right, 6 and 7 go fast. No worries. We're almost at the finish line, y'all. No, we tired. And it's a Friday. All right, so first thing I want you to do for number 6 is write it in radical form. Write this in radical form. What number goes in the elbow? The 2 or the 3? The 3. And then 8 goes underneath, and it is squared. Now, it is always easier. I'm going to say always. You can write it this way, but you can also write it where the 2 is the exponent on the outside. So the reason why is this. We're going to do 2 operations. We're going to take the cube root and then we're going to square it. It's always easier to start with the root. Now we could do 8 squared, get 64, and then take the cube root of 64. But when we get to the bigger numbers, it's a lot harder. So let's just start here. Does anybody know what number multiplies against itself 3 times to give us 8? 2. So this number here is going to change to a 2. Yes.
The 2 on the outside, doesn't that like apply to everything? So wouldn't that apply to 3 now?
No, that's the index. That's the index. You can't multiply the index by the exponent. All right, so now we're going to do our power, which will be 2 squared, and my final answer would be 4. All right, try to do number 7. Write it in radical form, find the root, and then do the power. correct answer. So you're gonna start off by taking the fourth root of 16. So figure out what number, fourth root means what number multiplies against itself 4 times to get to 16. That's what a fourth root is. So we're gonna take the fourth root of 16. We're gonna do that first. Then we will square our answer. So if you're not familiar with your fourths, just make a little chart. Take 2 to the power of 4. See what you get. 2 times 2 times 2 times 2. 16. So that tells me that the fourth root of 16 is 2. Now take that 2, raise it to a power of 3. 8. That would be your final answer. This has been a hard week. I am tired. All right. Now we did one of these yesterday with a common denominator. Now let's talk about what if we don't have a common denominator. Who remembers how to find common denominators? It's been a long time. So back in the day, I used to teach GED classes, but it's not even called the GED anymore. And we spend a lot of time focusing on finding common denominators. So this is what I used to do. So I have my 3 denominators, right? I have a 2. Let's go ahead and count by 2s. 2, 4, 6, 8. That's enough. We'll stop right there. Now let's look at our 3. Let's count by 3s. 3, 6, 9, 12. Let's stop right there. And now let's look at our 6s. We just do the first couple. 6, 12. Okay. Now, the common denominator is the number that all 3 rows have in common. That's all that means. What number did I write in blue, in red, and in green? 6. That's my common denominator. Okay, so what I have to do is rewrite it so that everything is over a 6. Now, fortunately, I don't need to do anything with the bottom. That already has my 6. So in order to do that, I need to multiply the 1/2 by 3. And I need to multiply the 4/3 by 2. And then everybody will have the same denominator. So that would give me x. Then I have 3/6 times x. Go ahead and see what you get. And you should get 8/6. That's divided by x 1/6. Okay, so let's do what we did yesterday. First, now that we have our common denominator, let's add the top. Go ahead and add 3/6 plus 8/6. So 3 plus 8 would be 11/6. And then we need to subtract. What's 10 minus 1? See, I said it. What's 11 minus 1? 10/6. All right. Write this in radical form and simplify it. Write it in radical form and simplify it. So if I have 10 people, how many groups of 6 can I make? How many would be left out? So that would give us, we have the 6th root of x to the power 10. How many groups of 6 can I make with 10 people? So if I actually take the time to make 10 x's, is that 10? 1, 2, 3, 4, 5, 6, 7, 8. Okay. And I circle a group of 6. See, I can only make one group, right? There's just one. So 1x, x to the power 1, that's what comes out. Make your radical. Don't forget to put the 6. How many did I leave out? 1, 2, 3, 4. That would be your answer. All right, last 3 questions. And the last one is the easiest one. Well, to me, it's the easiest one. All right, let's do a couple more exponents. Let's look at 9 first. Now we're adding in a negative. I'm going to write the rule for a negative exponent at the top because pretty sure we don't remember. When you have a negative exponent, you flip the base or take the reciprocal. That's what I'm doing. And then you make the exponent positive. Positive. Hopefully you all can see that. This is just the rule going all the way back to Algebra 1. That's how we handle a negative exponent. We take the base, we flip it, and then we change the negative 5/2 to a positive 5/2. Everybody tired? Fridays are hard. I think they're my hardest day. All right, so let's go ahead and look at number 9. So I'm going to take that 9/4, flip it, and it's going to become 4/9. And then the negative 5/2 becomes a positive 5/2. All right, so let's keep in mind that what this is saying is take the square root of 4/9 and then take that answer to the power of 5. See, as we have a 2, there's a 2 in the denominator. So that's the square root. Now, fortunately for us, they're both perfect squares. So go ahead and take the square root of 4 and the square root of 9. And that should be 2/3. And you're separating that. So you're actually taking 2 to the 5th over 3 to the 5th. That's what you're doing. So go ahead and do that. Get your final answer. I don't know if that's the right number. I'm trying to remember back from first period. It's 243? Okay. That would be your final answer to number 9. We can't reduce it. All right, let's go ahead and do number 10. Yes.
You square rooted 4/9 because the 5/2.
Right. So because the 2 is in the denominator, that means square root. If it was a 3, that would be cube root. But a 2 tells me to take the square root. Good question, though. All right. Anybody still copying down 9 because I wrote all over the board? Okay. Let's go ahead and look at number 10. So I'm going to flip it. Right now, this is over 1. So when I flip it, it becomes negative 1 over 8. And that becomes a positive 4/3. Now for this one, I'm going to separate it because I feel like cube roots are a little different. And remember, so if I were to write this in radical form, that would be the cube root of negative 1/8 to the power of 4. But I'm going to separate this to 2 questions because remember that you always look at the negative separate. So that's really what we're doing. So does anybody remember? What am I going to do with the negative? Do I leave it? Does it have to stay or can it come out? Looking at this number in the elbow. Who says it can come out? Because this is what? Odd. So this is going to change to a negative 1. But we're going to raise that to the power of 4. And what's negative 1 times negative 1 times negative 1 times negative 1? We just got to figure out, is it a positive 1 or is it a negative 1? If you're not sure, type it in your calculator with parentheses. But it is positive. Good. All right, now let's do the same thing with 8. If I take the cube root of 1, the cube root of 1 is just going to be 1. What's the cube root of 8? What number multiplied 3 times gives you 8? 2. So now figure out what that would be. Take 1 to the power of 4 and put that over 2 to the power of 4. So your final answer would just be a positive 1/16. All right, last question, and then we are finished with Appendix 10. I did shorten down 1.2. So I took all the graphing out. That's why I'm giving you all a worksheet for homework 5. Instead of, we're not going to mess with the book. Monday, we will finish up with our lesson. Then we'll have 2 days to review and take our test. It's really a quiz test. It's out of 70 points, so whatever you want to say it is, I don't know. We'll do that Thursday. All right, number 11. Okay, who remembers the rule? When you have a power on the outside, see not love, sit on up. If you have a power on the outside, what am I doing with that? With these, am I adding them, subtracting them, multiplying them, or dividing them? Who says add them? Not add them. Add it. I would add it if it was x to the 4th times x to the 1/2. That's addition. But this is x to the 4th to the power of 1/2. So that's not addition. What do we think it would be? Multiplication. This is multiplying. We're going to this is called power. I think it's called power of a power. I haven't taught Algebra 1 in a long, long time. But you multiply the exponents. I'm gonna abbreviate that. So if this were x to the fourth to the power of 2, let's just pretend it's not a fraction. If it was x to the fourth to the power of 2, that would be x to the power of 8, okay? So we're doing the same thing here. And lucky for us, all of our exponents are even. So when you multiply, you're just cutting these exponents in half. So we're taking half of 4, half of 8, and half of 2. So my final answer would be x squared, y to the fourth, and z to the first.